So here you have the list of all of the positive patients
Yes.
you
Well,
have.
this is the results from the COBAS, which is the thermocycler, which does the amplification. It gives us our end product, the amplicon here, that we need to put into this kind of anticoagulant system here with the troughs and the strips, but it works.
Yeah.
All right, but I'm just comparing my list here. So I'm only using the positives. The negatives, of course, we're not going to do. If they don't have any amplicons, they're not going to genotype. Okay, so
So based on the genotype of the virus, it depends how you treat it.
that's correct.
How do the treatments differ? Is it just the drugs that are used?
It's the drugs that are used. Some of them I don't think they can really do much for, but I know that, I'm not sure what the drug is, but I know they have something new that they can use now for, it's either 1A or 1B, I'm not really sure it is, because they're very interested now in distinguishing between subtype 1A and 1B. Often we can't, just because you see the chart here. Look at all the possibilities.
All of this is genotype 1.
All of this is genotype 1. If you have any of those, you can't say it's 1A or 1B. You can just say it's 1.
There's a little overlap bit right here.
Mm-hmm.
So is genotype 1 the most common?
Yes, it is. Here it is, yes. The second most common, I think, would be probably the 3s and the 2s. We rarely get a 4, 5, or 6. I don't know if we've ever had a 6, but we rarely do. And those would be maybe our universal traveling patients. We run a negative control with every assay and also an external positive control.
What type do you use for your positive control?
We actually use subtype 2. We used to use the 1s, but there's a reason we use 2 now. 2 doesn't have a number 6 band, and if there's often a little ghost number 6 band. So if we see that band on our external positive control, we know it's really not a positive. So anything that's that faint on another strip, we will ignore. If it's that strong, if it's stronger than that, then we're going to call it positive. So it's kind of our differentiation between what's negative and what's positive.
So they're being incubated now?
Incubating in a water bath. It's a 50-degree water bath, and it's a rocking water bath. So it's going to gently rock those back and forth for 1 hour.
So these have been in here for an hour now?
First I'm going to turn it off so they're not rocking anymore. Take these out and just set them down here just to break the water. That's just DI water and water bath. Set this on this platform. Be careful not to bump it and transfer any fluid from one to the other. Until it's washed, you still have sample in there, which could contaminate the adjacent well. I'm going to say they're in position on the platform and ready to go. Aspirates, then that particular line is going to drop in the stringent wash. It's pretty basic technology here, but it works.
So it's adding all these reagents, and then at the end it'll be dry and they'll just be lines?
That's right. That's right. This is a probe technology. It's a line probe assay. It's got the probes on the strips. They're not electrophoresis. They're actually placed on the strips. So when you look at the finished products, they're nice clean lines. There's no they don't look anything like the Western blots have been electrophoresed. These are manufactured and positioned in that spot right on these wells. On these strips. A little bit darker. They tend to fade a little bit with time. But you can see how clear they are. They're manufactured that way. So if you've got the amplicon has the particular probe, it will hybridize to that, and then you're going to have a color reaction. First, you're going to have a binding with the conjugate, and then you will have a washing away, and then it's an ELISA test. Then you're going to have a substrate for color development, and then you're going to have a stop solution at the end.
How long does this take?
This is about a little more than an hour for this. So it incubates for an hour, and it's got about another hour and 15, hour and a half before it gets finished with this. But there's going to be another step where we're going to put it back into the rocking water bath for a half an hour. And then we'll put it back on here, and it'll finish with the chemical steps. So it's not totally hands-on, but it's on and off.
Can you show me maybe a finished one and how you read it?
Yes. I can actually, they have a little strip here which helps you to read it. You can see, if you look at these, let me take one out of here so these are pretty nice. We take them out of the glossy area there. On these sheets that we mount them on, they do actually have the numbers here, and they're a little blurry and hard to read from being Xeroxed so many times. So it's easy to set this over the top of one, and you can see, looking for a nice, here's where this is a bit different here. You can see here the strip number 15 on top. You've got the marker line, that green line at the top there. The second one is going to be a conjugate control to make sure your conjugate was added. The amplification control is next to make sure you have amplified product. And then you're going to have, you can see how you can read these bands based on that little number next to them. 9, 10, 12, 5. And that is going to, we'll write that down on the sheet here for the positive lines. And then we're going to go to, can I show you the big sheet?
Yeah.
Right. Where did we put that? We have copies of it over here. People have one out. That we have one out. And then you would go to, theoretically here, to this sheet here, where it's going to show you a genotype 1A is going to have that band pattern. Genotype 2A or 2C would have that band pattern, any of those band patterns, all the way up to genotype 6.
So when you read it, do you mark it on that sheet yourself?
Yes, we do. We mark it on the sheet here. In this case, 1, 2, 13, 14, 15. And if you look at the sheet over here, you can see that 1, 2, 13, 14, 15 is a 3A. It's hard to see. It's all the way over here, the 13. You just kind of have to draw over here, 13, 14, 15. So that pattern is a 3A, according to Siemens line probe assay.
So that's not like a computer printout, that's someone had a...
No, this is manual.
Ah,
No,
old
it's all
school.
manual. This is old school. Yes, we have to read them ourselves, just like Western blots. We have to interpret them ourselves. We also have just recently started reporting them out, not as one, if there's a subtype, a genotype 1 that you can't differentiate between a 1A and 1B, there only is 1A and 1B. So we're now referring to those as 1A or 1B. I think the physicians like that better. It's still a 1, but it's 1A or 1B. The rest of them are pretty straightforward. We rarely will have a subtype that we'll have to call the company on because we're not sure what it is. And some instances, you can have a possible mix of 2 different genotypes too. That happens rarely, but it does happen. Take these off and set some of these on the strip to dry. Okay, the negative control has the conjugate control, so we know that the assay was valid, and it is negative, as it should be. It just has the conjugate control and nothing else. Number 2 has 1, 2, 3, 4, 5. as a 1A. Number 3, 1, 2, 3, 4, 6. That's a 1B. Number 4 is also 1, 2, 3, 4, 6. That's a 1B. This has a few light bands down here. I'm going to wait a little bit. They may dry. You can see these really faint bands here. This is the band right here, the number 6 band that we're going to call positive. If it's that intensity, and you can see it's very faint, if it's that intensity or greater, it's positive. If it's less than that, then we aren't going to consider it positive. Here's one that's slightly less here. This one would be 1, 2, 3, 4, 5. You can see there's a very, very faint one there. So number 12 is going to be 1, 2, 3, 4, 5.
What genotype is your control?
The positive control is a 2. If you look at it here, and when you get down to those lower bands, it's easier if you hold up the template here. It's 1, 2, 5, 9, 10, and 12. And if you look here, 1, 2, 5, let's see, we have 9, 10, and 12. 1, 2, 5, 9, 10, and 12, right here. 1, 2, 5, 9, 10, 12. 2B. That's a 2B. That's a previous positive patient, actually.
Oh, that's how you do it.
That we just saved and ran again. Boy, Dr. Yen will enter it in the computer, and then we're finished with that. And these results will be going out today.
Okay, thank you.
All right, thank you.